Today we're going to explore the differences between elements and compounds. By the end of this video, you will know what they are, how they are different, and you'll even be able to recognize them in everyday life. Everything around us, like air, water, metal, plastic, are all made up of matter. Let's start with something basic. What is matter? Matter is anything that has mass and takes up space. Your desk, the air you're breathing, and even your own body all are made up of matter. But matter comes in different forms. Some substances are made up of just one type of atom. Those are called elements. Others are made up of atoms that are chemically joined together. Those are called compounds. Let's find out how they differ. What is an element? An element is a pure substance made up of only one type of atom. It is the simplest kind of substance you can find. For example, the element oxygen is composed entirely of oxygen atoms, which are essential for respiration and comprise 21% of the atmosphere. And it is highly reactive. The element iron is made up of only iron atoms. Iron has uses in industrial applications like steel production for construction and manufacturing, such as nails, pipes, and other tools. Iron also has uses in biological functions where it is essential for creating hemoglobin and transporting oxygen in the blood. It is vital for plant and animal growth. There are currently 118 known elements, and they are all listed on the periodic table of elements. Let's take a look at the atomic foundation of an element. Each atom of an element is comprised of three primary subatomic particles. We have the protons that are positively charged, which define the element's identity or the atomic number. For example, carbon has an atomic number of 6. This means a carbon atom has 6 protons. The neutrons, which are neutrally charged, are essential for holding the nucleus together. Positively charged protons would otherwise repel each other, but neutrons' presence and the strong nuclear force overcome this repulsion. And we also have the electrons, which are negatively charged, that orbit the nucleus. Electrons can be transferred or shared between the atoms to form chemical bonds. Let's study the key properties of an element, starting with the physical properties. Elements exhibit distinct physical properties such as melting points, densities, conductivities, and states of matter at room temperature. Their properties are intrinsic to their atomic structure and bonding. Elements also have chemical properties that describe how an element interacts with other substances, including its reactivity, oxidation states, and tendency to form bonds. For example, highly reactive elements like sodium readily lose electrons, while neon is inert. Elements also have their periodic trends. The periodic table organizes elements by increasing atomic number, revealing recurring trends in their properties. Elements in the same group or column share similar chemical properties due to having the same number of valence electrons. Valence electrons are the electrons in the outermost shell of an atom that are involved in forming chemical bonds. Now, let's look at compounds. A compound is formed when two or more different elements chemically bond together in fixed, specific proportions, creating entirely new substance with unique properties. For example, When two hydrogen atoms bond to one oxygen atom, they make water with a chemical formula of H2O. The elements lose their individual properties to form a new substance. For instance, hydrogen and oxygen are both gases, but when they combine, they form water, which is a liquid. Water is essential for all known forms of life, covering 71% of the Earth's surface. Another example of a compound is sodium chloride, made from sodium, a metal, and chlorine, a poisonous gas. But together they make table salt that is safe to eat. Common table salt is vital for human health and food preservation. We also have carbon dioxide, which is formed when one carbon atom is bonded to two oxygen atoms. It is a greenhouse gas, but essential for plant photosynthesis. Let's look at the differences in composition and structure of elements versus compounds. Elements contain only one type of atom. The chemical and physical properties directly reflect the characteristics of that single atom type. They have uniform atomic structure and cannot be simplified further. Elements are represented by symbols like H for hydrogen, O for oxygen, and C for carbon. Compounds, on the other hand, are made up of two or more elements bonded in fixed ratios. They have a complex molecular structure and new properties emerge from bonding. They are represented by formulas like H2O for water or CO2 for carbon dioxide. So in short, elements are like the alphabet of chemistry, and compounds are like the words we build from those letters. This is how almost every compound on Earth is made through the bonding of elements. Let's look at the classification differences between elements and compounds. Elements can be classified based on metallic character, which helps predict chemical reactivity and bonding patterns in compounds. We have the metals that can lose electrons easily. The nonmetals can gain or share electrons, and the metalloids that exhibits intermediate behavior. Metals are shiny, conductive, malleable elements such as copper, aluminum, and gold. Nonmetals are dull and poor conductors such as sulfur, oxygen, and carbon, while metalloids have properties between metal and nonmetal like silicon and boron. Compounds can be classified based on the type of chemical bond, which depends on how atoms are held together inside the compound. We have the ionic compounds, covalent compounds, and metallic compounds. Ionic compounds are formed when the electrons are transferred from one atom to another. They have strong bonds, high melting points, and conduct electricity when dissolved in water. This usually happens between a metal and a nonmetal. For example, the bond between sodium and chlorine forms sodium chloride. Calcium and two fluorine atoms make calcium fluoride. Potassium and bromine form potassium bromide. Covalent compounds are formed when two atoms share electrons, which usually create weaker bonds, low melting points, and often exist as gases and liquids. For example, water, carbon dioxide, and ammonia. Metallic compounds are also known as alloys. They are formed when two or more metals are combined. The atoms share a sea of electrons, making them good conductors. For example, brass is made from a combination of copper and zinc. Steel is made from iron and carbon. Bronze is made from copper and tin.